Well, good morning, good afternoon, good evening, wherever you're joining from us to us today. This is Jyoti Dodia, and welcome to today's PowerVug session. This is the 95th session in the series. I've been running this since 2011 and have a lot of subscribers, so thank you for your support. Today, I'm really pleased to have Gareth Coates talk about HMC and VIOS tasks made easy with scripting and commands. It seems to be quite a hot topic out there. I've had a lot of interest, so I'm really pleased to have Gareth join us today to tell us about all the hints and tips. So over to you, Gareth.
Thanks, Jyoti, and good morning to everybody, or good afternoon, good evening. Jyoti contacted me and a few other people recently and asked if we'd be able to present a session on the VUG series, and I jumped at this one because I do enjoy using the HMC and the VIO server command line. And at first I was thinking, I wonder if I can stretch it out to half an hour, and then we decided to make it 90 minutes, and it's going to be tight to fit it in, to be honest, but I'm glad that I've got Nigel Griffiths on the line as well, because I can't actually see the text chat, so if you ask questions, hopefully Nigel can jump in and help you. So the idea of this session is to look at some useful tips and cover some best practices for using the command line and for scripting. Now, both of the HMC and the VIO server offer you a restricted shell. And so some things can be quite tricky, but we're going to try to make your life a bit easier. But this isn't going to be, as I say, a scripting 101, because we do assume that you know a bit about the HMC and a bit about the VIO server, and that you can do a bit of scripting already. So you might think that the restricted shell ties your hands behind your back, and to a certain extent it does. But there are some clever things that we can do to try to make our lives a bit easier. Now, I'm old enough to remember the good old days when computer hackers were skilled computer people. They weren't baddies. They were generally people who enjoyed trying to get things going, and they would work their way around problems. They weren't people who, as the Sunday newspapers call hackers, people who use bugs and exploits to break into security. So we're not going to be suggesting that you should do anything that you shouldn't be allowed to do, but what we're going to do is to try to help you make the most of the situation that we've got. So a restricted shell is pretty much the same as a normal shell, but there are some things that you can't do. So for example, you can't use the CD command. You can't change the variable shell or path or the environment. You can't specify any command that has a slash in it, and you can't source or use the dot command with any command that's got a slash in it, any file name with a slash in it. And also you can't redirect output. Although there are things that we can do to try to get around this situation. So I'm not going to go into all of the details of what the restricted bash shell is, or what the restricted corn shell is. You can look at those on the manual pages. And of course, in the VIO server, you can just run OEM setup env. You should all know that if you're familiar with the VIO server. But the clue is in the command name. It's an environment to allow you to set up environments for OEM-based systems, for example, setting up device drivers for third-party storage and so on. So basically, you shouldn't be doing your day-to-day work in that shell. People do, but they shouldn't. IBM do stress that you shouldn't. And you need to be very careful, because if you break something in the VIO server, you could be adversely affecting all of the clients, all of the virtual machines, all of the DLPARs which are using the VIO server. And I like this little mantra that I came across: your system is our concern, but it's your responsibility. So I do caution you that everything that I say in this presentation, you need to be careful that you understand the implications of what happens when you hit the enter key, to run a script. And on one of IBM's web pages, there's a link to it later on. It does say to you here, use this with caution. It's critical to your environment, and damage done can have repercussions on all of your LPARs. So do be careful. There's also a nice quote that I like here. Unix was not designed to stop you from doing stupid things, because that would stop you from doing clever things. So there are some clever things that you can do, but do realize that you can completely break your system either as HSC root on the HMC or as padmin on the VIO server. So on the HMC, this is what's on your path, HMC RBin and user HMC RBin. So there's some useful things in there, but not very much. That's in HMC RBin. In user HMC RBin, there is a lot of stuff. Most of them are classic HMC commands, but there are some operating system commands in there as well, things like man, CP, RM, and so on. Now, if you are going to be scripting on the HMC or the VIO server, it's worth getting to know what commands are available to you. But I'm not going to go through each and every one of them in turn. If I go on to the next page, this is what's on the path in the VIO server. And again, I'd encourage you to familiarize yourselves with what's available. There's also on the VIO server many aliases, and many of them are actually expecting you, or what they do is they run the command using IOSCLI, IO server command line interpreter, as a sort of prefix. It's a single, if you like, wrapper which wraps around the VIO server version of the commands. So, for example, the make user command you might think you know from AIX, but the one in the VIO server is subtly different. And there are web pages around where you can find on IBM in Knowledge Center, which will talk about some of the differences that there are. And of course, we'll be covering some of them today. So there are also the shell built-ins. You can see some of them there, not all of them by any means. And you can generally use those, but obviously it's restricted shell, so you can't be using the CD command. It's worth as well getting to know these. If you're an experienced scripter, you're probably familiar with quite a few of them already. It's very useful to exchange authentication keys between, for example, your home system or the system which you normally use, and also potentially your laptop or your desktop PC, whatever it is that you use. So there's a variety of keys that can be used, and we're going to be looking at an example. But one thing I'd like to caution you about is that just because you are setting up a key, security key, if you want to transfer it to the HMC or the VIO server, don't just overwrite the file, because somebody else may have already got a key there. So the thing to do is to copy the file to your system, add your own key, your own public key, and then copy it back to the HMC or the VIO server. I'll be covering how to do it in just a moment. Now, I want to talk a little while about user IDs. So the classic ones are HSC root on the HMC and padmin on the VIO server. If everybody uses those particular usernames, it's very difficult to see who's been doing what. And also, if 3 people, for example, are using HSC root, then the history file for HSC root will be shared amongst all of them, which can cause a little bit of confusion. So it is possible, and some people think it's advantageous, to create other users. So you get a separate audit trail, you can look at individual histories, and also, particularly, you can restrict access to particular resources. And should somebody leave the company or change department, it's far easier to lock out a user called, I don't know, Gareth, for example, and not the user called Nigel, or whatever the situation is. but there can be some disadvantages. So for example, on the HMC, something I quite like to do is to tail-f/var/log/messages, and so I see all the messages as they appear on the screen. So for example, if you're powering on a server in the sense of actually putting in the power cables, you can see the HMC receiving the DHCP requests and so on. But if you look at the file, the permissions are read-write for root, and they are read for root, and they are nothing for any other user. So the HSC root user is in the group root, and so is able to read the varlog messages file, but another user, although he or she might be an HMC superadmin, would not be able to read the messages file. So you do need to be thoughtful about that sort of thing. Also on the HMC, I worked on this for a very big customer who demanded that they had a minimum number of characters in the password for the HMC of 12. And so you can change the password policy. I think that the particular parameters are fairly self-explanatory, so you can set the minimum password age and days and maximum, and the minimum number of digits, and whether or not you need lowercase and so on. And on the right hand side you can see how you can change the policy as well. Set it, change it, put a particular user into to have a particular policy and so on. So this is how you make a new HMC user using the GUI. So you'd take manage users and profiles, add a user, enter the details, fill in the boxes. Don't forget to take the user properties if you want the person to be able to access the system remotely using the web. And also you can set up the task role. That's an important function. It's also possible to set up your own task roles. And so you can set a resource role to allow people to access just particular systems, and for task roles you can allow them to do different things. It's actually very granular, the amount of configuration that you can do. So for example, you could have a user who is only able to power on a particular system. They can't power it off, but they can power it on. You can get very granular. But we're talking about using the command line. So this would be the way that you would be doing this on the command line. There's the make HMC user command, the ls, the ch, and the rm HMC user commands. And there are manual pages which cover all of these commands. But you can see there's an example there of how you can create a user for the HMC, call in scriptor2, description. You can put the quotes in there, and you get the ability to have free space, white space in there. Task role I've set up was HMC superadmin, and I've allowed all the system resources. But you can see here that underneath that I've looked at a resource role called Power 8, and this just allows the users to do things with the Power 8 servers which we had on the system. So you can be quite granular with what's going on. So on the VIO server, you've got the make user, ls user, ch user, and rm user command, very similar. So making a user is very simple, and you just enter the password on the command line there a couple of times, and the user is created. So let's have a look at using these new users then. So we SSH scripter at HMC 16, and we use a command pwd, print the working directory. First time you do it, you have a little bit of a dialogue with SSH, and it puts keys into various files and so on. It permanently adds the host to the known host list, and it prompts you for the password. The next time you do it, you don't have the dialogue, but you do have to enter the password. So this is standard SSH restrictions. Similar thing happens on the VIO server. You get prompted for the password. So to avoid having to enter passwords, we exchange the SSH keys. So first thing we do is make a key. As I say, we don't actually overwrite the target file, but we copy it across, and I'll show you how you do that. So this is on an AIX system. You can do it just as well on a Linux system. You run a command ssh-keygen, and it will generate a key for you. And you can see down here in the .ssh directory, it's created an ID underscore RSA, which is a private key, and an ID underscore RSA .pub, which is the public key. What we then do is, I'm showing you here, we're copying the authorized keys to file from HMC 16 into a local file, and I've called it authorized underscore keys to underscore HMC 16. Then I concatenate my public key onto that file, and then I copy it back again. I have to enter the password when I'm copying the file because the keys haven't yet been exchanged. Once they have been exchanged, I can then just run the SSH command, and the command will execute without me being prompted for a password. So this is very useful. It saves time. It means that you don't have to enter the password, and it is actually more secure to do things this way, exchanging the keys rather than typing passwords in. Although the passwords are hidden on the screen, it saves any sniffing of the passwords going across. Similarly, for the VIO server, we copy it across. Notice that the file is called authorized keys to again. We copy it across, we concatenate our key onto it, and we send it back again. But this time, when I try to use SSH, it still prompts me for a password. So let's have a look at this. Well, in the sshd config file in the etc ssh directory, it tells me that the authorized keys file is .ssh authorized keys. So the default for SSH is to read both authorized keys and authorized keys too, but God bless IBM, they've changed it. So what we have to do is somehow enable it so that you can have the authorization. And what I tend to do is become root with OEM setup env, and then I make a hard link in the .ssh directory between authorized keys to and authorized keys, and then lo and behold, I can actually log in without having to enter the password. If you use PuTTY, many people do, you can run PuTTY and that will generate, allow you to generate a public and private key pair, and you can save them onto your hard disk, and you are then able to use them to go directly from your desktop onto the target systems as well. So here you can see that I've created a file called $ATS gaztp.ppk. It's my key, and I can use that to authenticate, and I can also use it for other things such as FileZilla, which is a very useful mechanism for FTPing or SCPing files around over networks. So here we go. We've got it all set up now. We can execute commands without having to enter passwords. And so now from my local system, my home machine, I can run a command on the HMC or indeed on the VIO server, and I can actually put effectively a pipeline or a set of commands into a single SSH command to run on the target machine. So you can see on the left here, I'm SSHing into the HMC, I'm running echo, I'm echoing who am I, and then I'm doing ls HMC-V, which shows me the software versions. Notice that I've put some funny escape characters in. You can see on the right hand side that escape open square brackets 7M will set you into what's called standout mode, SMSO, set mode standout, and escape open square bracket 27M will do an RMSO, remove mode standout. And there's also other codes for things like underlining. I find this actually very useful for making the output to my scripts nicely formatted. Similarly, we can do the same thing on the VIO server. So what does this mean? Well, it means that I can now write nice complicated scripts on my local machine using my favorite editor. In my case, that happens to be VI, the Visual Interactive Editor, and it allows you to pull output back to the home system, which means that you can then manipulate it and parse it with whatever tools you particularly like, for example, Awk or Python or Perl or whatever you like. If your system is able to send email, you can also capture information from your HMC or your VIO server and email it to yourself. Just as an example, I have a cron job which runs on my local machine, and every month it finds out the hardware time of all of our servers and it sends it back to me, so I can notice if the time is wandering. So very, very powerful facility here. On my home system, I have a useful set of hard links. If I run ls-li, the L is the long listing, as you know, and the I, the I tells me the inode number. So I've got HMC 10, 11, 12, 13, 14, 15, 16. These all happen to be in directory user local bin on my home system, and they all have the same inode. So they are identical files. They are the same file. They just have several entries in the directory pointing to the blocks in the file system. So if I cat one of them, you can see that it says HMC equals $base name $0. So what does that mean? Well, it means that the name of the HMC variable is going to be the name of the file. So for example, if I run HMC 10, the variable HMC will be HMC 10. Then I can SSH into that particular HMC using the SSH HMC root command, for example, there. And $@ means put all of the positional parameters at the end of the SSH command separated by double quotes. And so, for example, you can see there in the box, I run HMC 16, who am I, semicolon date, and sure enough, it runs those commands for me. I use that absolutely every day. So the HMC is an appliance, and you cannot legitimately save a script locally. You can't redirect, but there is a couple of ways that you can do things. You can SCP files in, and although you don't have access to VI, you do have the command rnvi-f, which is effectively the HMC's way of letting you run VI. And so that means that you can actually create files on the HMC. On the VIO server, you can run OEM setup env. You can create scripts locally that way, and you can save it in $path, but it's not a great idea. As you probably saw earlier, your home directory is on your path, and so it's an easy way for you to put something onto the path on the VIO server. One thing to be careful of, though, is that if you do create your own files on the VIO server, they will not be, if you like, standard VIO server files. And in the event of coming to do an upgrade, if you're upgrading from version 2 to version 3 of the VIO server, it may well be that the files just get lost. And so if you do it, please do keep a backup on your own system. Okay, so on the VIO server, you do have access to VI, and you can do this. So you can VI, for example, G, put it into your home directory, and you can then chmod it, and then you can run the command. As I say, I'd advise you to probably don't do that, but rather write scripts on your home machine and SSH them onto the VIO server. Now, here's a great tip that I use use it all the time on the HMC. I create a file with some useful variables in. I've already mentioned some of the variables here, so set mode, underline, and so on. If you hit Control V and then the escape key, that will insert the escape character for you. And I've also got here a list of our machines and my home logical partition. So, for example, we have a computer called P9-S922-Amber, but obviously Nigel and I just call it Amber. We've got a system called P9924 Red, but we just call it Red. But the long names are the ones which are used by the HMC for the commands. And because my home DLPAR was created using PowerVC, it's got an abysmal name with a load of hexadecimal characters at the end, but I just call it VM220. So if you create that file, for example, keep it in your home directory on the HMC, you can then source it using the dot command. So dot space set underscore variables will read into my current shell all of those variables, and I can then use those variables, which I can easily remember. So for example, lssyscfg -rsys -m $amber -f name type model state will show me that the system is running its operating mode and its machine type model number. And you can use these commands equally on the VIO server. So that's a very useful way of doing things to make your life easy when you're using the command line. Another thing here, many HMC commands will just provide you with one very long line of output, comma separated usually, and you can convert them into individual lines using the sed command. Sed is on the HMC. And you might ask yourself, well, why would you want to do that? And well, you see here, it's far easier to understand these lines when they are on, when each of the sections is on a separate line rather than all together. There's no awk on the HMC, but there is awk on my home system, so I can pull the file back to my home system if I want to and run awk on it. But here's an example. If I run ls HMC-n and look for the IPv4 addresses, well, they're all on one line in the top example, but if I pipe it through that sed string and then grep it, you can see that I'm getting the actual IPv version 4 addresses for each of the 4 ports on this particular HMC. That's very useful for building into longer scripts. Now, I advised you earlier to familiarize yourself with the commands on the HMC. Quite often they come in groups of 4 or more. So the CH, LS, MK, and RM sort of groupings that we've talked about before. And it's worth checking the manual pages out for these because, for example, on the filters, quite often you'll find that the filters will be in maybe the CH command, but they won't necessarily be in the man page for the MK command or the LS command. So it's worth checking out the manual pages for all of them. I'm a great believer in reading the manual. It also gives you insights into some of the options which aren't necessarily immediately obvious. So it's certainly worth reading those man pages. Now, developing a script. Well, as I said, this isn't really scripting 101, but the usual practices for scripting would be, well, work out what you're trying to do. Maybe produce a flowchart. It depends on how complicated the particular objective is. If all you want to do is a very simple thing, it's just really a case of finding out the commands that you need to run it. If it's far more complicated, then you probably would benefit from having a flowchart. Also, you can build up a sort of library of useful commands and then use them together to produce a larger effort. So then you write the script, you debug it, you tweak it, you debug it, you tweak it, you debug it, you tweak it. Eventually, hopefully, you've got it to a point where everything is good. Usually, I try to work out the individual syntax on the command line. Then you can work out some loops. Error checking can be really an optional thing. For example, you might develop a script which will look for all of the LPARs on a particular server. And then you will say, okay, well, go into each and every one of the servers and tell me a list of the names of all of the LPARs. Well, that's fine, apart from there are some servers which can be managed by your HMC which don't have any LPARs, and they can't have any LPARs, so you get an error message. You might not worry about that. That might be something that you're prepared to put up with, or potentially you could use grep at some point in the loop to take out the systems which are going to give you the error message. We'll see some of this later on. Generally speaking, things are pretty safe for the HMC or the VIO server because, as we said, they are a restricted shell. But do remember what Doug Gwynn said, you can do clever things, and so you can do silly things as well. So, you know, if you get your command wrong, you could break your system. So if you use the RM version of the command instead of the CH version of the command, for example, you could end up doing something pretty sad. Obviously, the usual sort of precautions are there. You can't remove an LPAR if it's currently running. The HMC just won't let you do that. But you do need to be careful. As I say, you need to be aware of what's going to happen when you press the enter key.
Gareth,
that's me.
Interruption. So there's a question here from Frank. You showed using SED for separating HMC output into multiple lines. How do you work around those nasty attributes that show multiple values, comma separated within double quotes?
Good question. And I'm thinking about it, but I don't think I want to particularly answer it right now.
Maybe one to take away with us.
Yeah, could Frank send me an email perhaps to remind me about it afterwards? Yeah, I don't know. Several things are going through my mind at the moment. Generally speaking, it's not going to be a problem to me. As I say, there are things that you can live with when you're playing around on the command line. If you're writing a script that's going to be run repeatedly for different things, then that's another matter. So if he's got a particular instance in mind, then drop me an email and I'll try and help him out.
Thank you, Gareth. And just a reminder to everyone, if you do have any questions, just post them to the chat window. If you can send to everyone, that makes it easier for us, and I'll monitor the chat window. Thank you. Back to you, Gareth.
Okay. So I'm just an example here, a few things that you can do to find out and display the operating system level of all of the LPARs. You want to, this is working out the flow of the script. You connect to the HMC, you get a list of all of the systems. For each system, you then list the LPAR and the operating system level, and you display the output. All of this can be done using commands on the HMC. So let's have a look. So this is the command that you use to list all of the systems, and you get a name for each of them. So that's okay, but we've got some BMC based machines in here. They won't have any LPARs. Also notice that they are actually in the order, I think they're in the order that they were connected to the HMC. So P8, P7, P8, 7, P8, 9, P8. So we might want to be using the sort command. So we just put that in our mind. We'll maybe grep out the BMCs and we'll use the sort command. So listing the LPAR and getting the operating system level. So this was just for one particular server here, LSSCFG -R LPAR. So the resources that I'm looking at is the LPAR. -M $amber. I set the amber variable to be the P9-S922-amber, hyphen capital F. So the fields it's going to print are the name and the operating system version. And so, yeah, it goes through VM224 unknown. The operating system isn't telling me the version. That's actually because the VM224's not got the RMC code on. It's a Linux DLPAR. I happen to know that. We've got some VIO servers, we've got a broken VIO server, and we've got some good versions Linux, and also a version of AIX there. But again, we'll want to put in some sorts, and also, of course, if we're doing this for all machines, we want to know which machine this is on, so we'll put the system name at the beginning. So here's the command that we'd actually come up with, for example. So I'm listing the system configuration for resource name, sorry, the resource type is system, and I'm printing the name. I'm grepping out the BMC with a grep-vi. I'm sorting that, and then I'm piping that into a while loop. So for each server, I'm then going to do and list the system configuration on that server, resource type of logical partition, and I'll print out the name and the operating system version, and then I'm going to pipe that into sed and put the server name at the beginning of the line. Now, I'm not saying that this is the most efficient way of doing it, but it's actually a very straightforward and simple script to understand. And this is the output. No, sorry, this is not the output. This is how I would actually run the command from my home machine. So I would run HMC user equals scripter at HMC. I SSH into it, and then I run the commands remotely, and the system would output the information on my local window. Another command here, I've got a problem here of some of the WebEx windows in front of me, so I can't see what I'm looking at. This is a script on my local machine called get_ATS_WWPNs, so worldwide port names. And so what this does is it goes off into the it SSHs a command onto the HMC, and it goes in to look for all of the systems and to get the information about the worldwide port names. And you can see the output that we get here. So here, as an example, red system doesn't have any fiber channel cards, so we don't see any worldwide port names, and the same thing here with the BMC based machines. So if you are able to accept that kind of what's the word, I don't know, situation, then all well and good. Otherwise, you need to try to work on the script so that it doesn't give you these little quirks, if you will. I wrote the script a long time ago, quite happy with it. It means that instead of having to rebuild it again, I can just go into use a local bin, find the WWPN's file, and run it. So here's another useful, very simple script. It goes off and it finds for all of the FSP-based machines, I'm using a grep-v BMC, it finds the LMB size, the logical memory block size. This is very important. It's called the memory region size in the hardware resources. It's a bit annoying that the field is called memory region size, but everybody calls it the LMB. But it allows you to find out the LMBs on all of your SIG, and the source machine have the same LMB size. I knocked up a little script here a while ago when we were first playing around with live partition mobility. We wanted to be able to demonstrate it, and we used a great little program that Nigel wrote called Wiggly Worms, which has worms going around the system, and you can see them moving, and when the LPM actually starts to work, there is a pause and then it starts up again. But in order to be able to find the partition, because we've been moving it around, we needed to know where it was, which is okay if you just moved it, but 2 weeks later you didn't know where it was. So here we go. I've created a variable called needle. I'm looking for a needle in a haystack, as it were, and I SSH into the HMC, and I go to list the names of the machines, and for each of them I go to look for an LPAR which has the regular expression $needle in it. So for example, I can say where is LPAR blue, and it tells me that the LPAR called W3-blue is on a machine called red. That's because we've live partition mobility it away from a machine called blue, and we got rid of blue because it was an old Power 4 or Power 5 machine, and it's been upgraded and through the ages, but we still need to keep the LPAR called blue so that we know what it is. That's all well and good. And also you can see here we can have multiple LPARs, for example, because that's the way that Granular works. It's fine for us. That's exactly what we need. It might be that you need to find an exact string, in which case, you could use fgrep and write the scripts accordingly. So be careful, but you can be doing very powerful things using the command line here. Okay. Now, let's have a look at the quoting in this particular command, because quoting is a very, very complex subject when it comes to writing the scripts and executing them. So the first thing I'm doing is I'm exporting this script is written on my local Unix machine. I create a variable called needle and I export it, and I've got that in red. I then SSH as HSC root into HMC 16, and I open the double quotes. And the double quotes are paired with the double quote at the bottom line here. You notice that I've got a set-xv in there, but it's commented out. Set xv will show you, it'll basically echo onto the output every line as it's executed and as it's passed by the shell. So I run the familiar lsyscfg-rsys-fname pipe to while read, and I read a system, so a variable called sys. Then I do for each of those sys variables an lsyscfg-rlpar, so I'm looking at the resource of an lpar -m, and then notice here the sys, it's in the curly braces, which is just the standard syntax, but I have to backslash the $, because otherwise it's not going to be read. It's going to be expanded by the local shell. And I'm printing out the name. This -f name is the name of the LPAR, and then I pipe that into while read LPAR, and that's in the pale blue. And again, I've got to, in the next line, I've got to backslash the $, for the LPAR. And then I pipe it to grep-qi $needle. This isn't quoted though, because the $needle has to be passed through from the sourcing shell. So you can see here that sometimes you need to do the quotes and sometimes you don't. And then I echo -e \sys, and then I've got 3 backslashes there before the T. Now the 2 backslashes before the T are because \t is the escape character to give me a tab, but I need to backslash that, and so that's why there are 3 backslashes there. And then I've got \$LPAR to print out the name of the LPAR. So there's different levels of quoting using backslashes that you use when you're writing these scripts. And this is actually quite a simple script. So things can get quite complicated if we're doing more, as you'll see in just a short while. So let me go down. So one of the things that we were doing when we got our first Power 9 computer was that we wanted to check that LPM worked between a Power 8 computer and a Power 9 computer. It did. Great, tick in the box. And then we decided that, well, we'd actually put it under a bit of pressure. And so I wrote a script, it's called Ping Pong, and Ping Pong would use LPM to move a particular LPAR from a Power 8 computer to a Power 9 computer. And just for fun, I was using two different HMCs, we'd move it from Power 8 to Power 9. We'd wait for a little while, and then we'd put it back from the Power 9 to the Power 8, wait for a little while, send it back again. During the testing, we actually got, you can see here down on the left-hand side, we did 32,874 migrations between Power 8 and Power 9 before the Power 9 was actually GA. Now, when we were doing this, we pinged and ponged it about 10 times, and then it stopped working. And we talked to the people back in Austin about it, and they said, "Oh, you're not waiting long enough between the ping and the pong." And so I increased the sleep a little bit. I eventually took it up to about 5 minutes, and then it crashed again and again. And they were a bit confused, and then they found out that actually there was a bug. We'd found a bug that had been there actually from pretty well the year dot for LPM. And we were able to help them to solve the problem. Now, because the program was running at all sorts of times of day and night, they wanted me to send them a snap from the VIO servers, but the snap had to be taken within an hour of the actual problem occurring. And so you can see here that in this particular loop, I was running an SSH to the HMC, and then I was checking the result, $? And if the result was not equal to 0, in other words, if the system had failed to do the LPM, it would then $, it would then run what was in the braces, and then SSH a command out to the VIO server. And the command it ran was CLF FDC, that's collect the first failure data capture information. And I was running on a particular VIO server, which was in the variable $VIOS. And the nice thing about that is that it captures snap information from all of the servers in all of the VIO servers in the cluster, and it would store it into a file called underneath /home iOS logs SSP _ FFDC. So even if it died at 2 o'clock in the morning when I wasn't on the system, it would SSH the command onto the VIO server, and it would save the snap data. And in the morning, I'd then be able to upload the snap to the guys in the States. So you can see that in the overall script on my home machine, I'm able to SSH commands both to the VIO server and to the HMC. Now, I want to cover a few things here. One of the ones to cover is dynamic logical partitioning. And so you can see that we've got the ls hwres command here, and this is showing me the particular information about the processors. So this is showing me the current minimum 0.5, the current number that I have in the LPAR 3.0, and the maximum 4.0. And I've also got the information for the virtual processors. So here we've got 1, 4, and 4, so a minimum of 1, a current of 4, maximum of 4, and the last figure here is the uncapped weight, which is 128. So equally, you can use the lshwres command to give you the information for the memory, and it's given me here the information in gigabytes. And I can use the chhwres command to make modifications. So change hardware res on the machine, $system. The R is clearly the resource processor or memory. And the -O gives me an option. R is for remove, S is for set, and A is for add. So if it's an add or remove, you give it a quantity, and if it's the set, you set it to the exact value that you want. Excuse me, I'm just going to take a drink.
And while Gareth is doing that, just a quick comment, I guess. There have been some comments in the chat window regarding the sed command. There's been some discussion on that, so we can take a look at that at the end of the webinar or at the end of the session, if you like.
Yeah, I can't see the text chat when I'm in presentation mode on.
That's fine. We'll take it. Thank you to everyone who's been commenting. We'll look at that at the end of the session.
Okay, how are we doing on time? 5 to 11. Okay. So I need to click there and page down. Another thing to look at here is DPO, Dynamic Platform Optimizer. I spell it with an S because I don't speak American. And I liken this to the old puzzle where you've got everything in a mess and you're trying to get it sorted out into a nice order. This was particularly useful in the Power 7 timeframe, but due to the fact that the Power 8 and Power 9 architectures much flatter, it's not quite so important. But we can run the ls-memopt command, and we can get it to calculate the score for each of the LPARs. And so you can see here that we've got the names of the LPARs, and it's showing me the current score, which is in arbitrary units between 0 and 100. And it's got the predicted score, which is in the case for AMBER VIOS 3, it's currently 80, which is a little bit fragmented, and it reckons that if I run the command to actually optimize the memory, it could get it to 100. And so the way to do it is to run optmem, and you can say prioritize AMBER VIOS 3 if you want to, and -O start, and it will actually do the optimization. So fairly standard, straightforward commands, but something you might think about here is running the calc score. If you're not doing LPM and you're not starting partitions, it's not going to change. But pardon me, you can consider running this using cron, for example, on your home machine. So you can maybe on a weekly basis or on a daily basis, if you want to, you can go and get the calculated scores and the predicted scores for your systems, and you could write a script which checks out what they are and maybe sends you an email either with the figures in, or maybe you could be clever and say, well, I think that I want to be told if there's any system which has got a current score which is more than 20 away from the predicted score. And so you can be very clever with the way that you're crafting your scripts. Now, arrays. I don't know if you use arrays. Feel free to make a note in the chat if you do. Very powerful feature built into the Corn shell and the Bash. Obviously, other programming languages have them as well. But as an example, here we've got an array. It's a one-dimensional array. It's got 7 elements. The array is called pet. And so pet0, element pet0 contains the variable cat, the word cat, and pet1, dog, and you can see the other ones. So very easy to actually use them and very powerful facilities. So let's create an array. We'll create an array called machines. And the elements of the array will be the names of the machines managed by a particular HMC. So in AIX, we run set -A machines, the name of the array, and then we create the array using the output of command. So we run the standard familiar command that I've been showing you throughout, the lssyscfg-r sys-f name. And so that will create an array machines, and each of the elements will be the name of one of the machines managed by this HMC. It's easy as A to Z. On Bash, it's even easier. It's ABC. So here you just you don't need to hyphen A. You just create the variable, and if the variable you're making has got spaces in, it will become an array. It's so easy. So let's have a look at how you use it. Well, effectively you use the elements of the array using the format of the variable name or the array name, and then square brackets and the element number. And so here, for example, I've started off with an element number of 0 because that's the first element of the array. And so I say, while the number of the elements is less than the number of elements in the array machines, do echo the element number, which is 0, 1, 2, 3, 4, 5, and so on, then a tab, and then the element in the array. And so you can see here that I'm just listing out the array. Well, so far, there's nothing really much has been gained from it. So what? Well, I created a facility called SARM. SARM stood for the Power Server and LPAR menu. And so if I run the command SARM, it gives me a couple of HMCs here to choose from, 0 and 1. So I pick a particular HMC, and then it goes into the HMC and it asks me to either select a managed server, or it'll give me some information about the HMC. So I chose 0, which is to select a managed server, and it's now giving me a list of all of the machines. Familiar, a bit like the last screen. And so I can select a particular machine by number, and then it says to me, so I've selected here machine number 10, which is amber. It asks me to either select an LPAR on the machine or to give me some information about the managed server. And then I said, okay, give me the list of LPARs, and it gives me here the list of the LPARs, and I can select a particular LPAR and I can do something with it. So for example, list of resources, activate the normal profile, activate it into SMS mode, open a virtual terminal, and so on. Now, the thing which is clever about this is that there is only one configuration file, which is user local lib SARM, the actual executables in user local bin SARM. And so effectively, I just have one configuration file, which is a list of my HMCs, and the script goes out and it gets the list of the HMCs, puts them into an array. There's 2 of them. Then for the chosen HMC, it goes and gets a list of the servers and puts them into an array. And then for the chosen server, it gets a list of the LPARs and puts them into an array. And so there's brilliant, there's no maintenance. If we add another server, if we create another 35 LPARs, you don't have to worry about changing this script. It just automatically works everything out for you. It's also very performant. When I was writing it, I was thinking it's going to be very slow. There's a lot of manipulation going on, a lot of SSHing backwards and forwards, but it's very, very quick. I can, if we get a bit of time, I might show you a demonstration a bit later on. So let me click back on the backdrop. I've also got a suite of scripts called MALT, which stands for Make an LPAR Tool. Now, this is actually one of the most complicated things that you might come across doing when you're trying to program on the HMC. So MALT has got a configuration file. The default is called config. MALT is the program which actually runs everything. There's a little script called BK profiles that backs up the profiles. It runs BK prof data on the HMC. We've got a DLPAR command. We've got a CH profile command. So we change the virtual adapters in the VIO server. And we've got the command that actually runs the making of the new client LPAR. So let's have a look at some of the data here. So this is the actual script to make the logical partitions. Now I'm going to put this suite of tools up onto my blog, which I've got a link to as well. Now this is quite a complicated script. It starts off here with an SSH into HSC root at the HMC defined in the configuration file. All the variables come from the configuration file, and that double quote there. Can you see the pointer here, Jotty?
I can, yes.
You can. Okay, so great. So the double quote here is paired with this double quote down here at the bottom on the right hand side. So there's a lot going on in between. So we run a make sys CFG -r LPAR, making an LPAR on the machine called $match. -I is the input data. So from here, -I, and then we put a double quote, but it's got to be quoted by a backslash, and that double quote there is paired down to this one here on the bottom right hand side. These backslashes here are just effectively before the or at the end of the line, and so this is all one line. Okay, so notice here the 3 backslashes because we are having to send a double quote through, and so we've got to backslash the double quote, but we've also got to backslash the backslash. So it gets to be quite complicated. This section here sets up the virtual the virtual SCSI adapters. So in the configuration file, we've defined what the slot numbers are, what the server IDs are, what the slots in the server are, and whether or not it's required. And then we've got 2 slots here because we've got 2 VIO servers. So we've got SCSI adapter, virtual SCSI adapter in the client, which is connected to the VIO server 1 and VIO server 2, or 0 and 1, depending on how you want to start your counting. Notice again here the 3 backslashes before the quote, and then we've got a comma. Now we come on to the virtual Ethernet adapters. On this particular configuration, we're going to have 4 virtual Ethernet adapters. The configuration file defines where we're connecting everything to. That's the tricky part out of the way. Now we come on to individual things like the LPAR name, what the ID is going to be, what kind of a environment it is, Alex Linux, is it a VIO server, IMEI, work groups, things like this, desired number of processors and all of the processor information, the amount of memory, and so on, maximum number of virtual slots, and when we run the script, it will go away and create this LPAR for us. So this is what happens when I run it. So I've configured up created the configuration file, and I run MALT, and this is what happens. You notice I've got the highlighting here just so it marks it out. It gives us a bit of formatting, and it asks me if I want to continue, because we want to be careful. We don't want to accidentally type things in, and so it's asking me if I want to continue, and I say yes. It backs up the profile definitions. If that doesn't work, it fails and it will exit. Then it creates the virtual SCSI adapters in the profiles of the VIO servers. It starts VIO server 1, VIO server 2. Then it creates the VIO servers in the actual LPAR running. So first part is doing it in the profiles, and the next part's doing it for real in the in the running server using DLPAR. Now, when I originally wrote this, we didn't have the ability to synchronize between the running system and the partition profiles, so I could probably simplify this script a bit. Then it moves on to actually creating the LPAR, and so you can see here that in basically 14 seconds, in 14 seconds, it has created the partition and created and edited the two profiles, one for each of the VIO servers. Did it actually work? Well, yes, we can run the LSCCFG, and it's created me this partition, and it's created me this profile. So the profile was called normal, and the LPAR was VM107-MALT. So yes, it did create the partition. When I was doing training for IBM, I would run a script similar to this, and it would the first part would destroy all of the machines. I actually set the machines back to factory defaults. It would then power them on. It would then create VIO servers. I could NIM install the VIO servers. I would then create the client partitions, and NIM would then go in and install the operating systems. In fact, we got even further. We got to the point where at lunchtime on a Friday, cron would kick in, and it would do this to a dozen machines, and so the machines were completely refreshed every day, every weekend, for a fresh start on the Monday morning. So it's it's a very powerful way of creating a script. Of course, we wrote this before PowerVC was there. PowerVC might be the way that you'd actually do it, but this is a useful thing to be aware of.
Gareth,
Yes.
just before you carry on, I just thought this might be a good time for you to get a little breather and for me to just mention a couple of things. So there was a question about recording of the session. Yes, this session is being recorded, and I will make the replay and the presentation slide material available hopefully later on today. So you'll get notified if you're subscribed to the PowerVug the webinar series. If you're not, then please send me an email. I'll put some details into the chat window. There have been a couple more questions which Nigel has fielded. Thank you. And we'll take the rest towards the end. And I just wanted to highlight a few more sessions that are coming up in this series, and for you to save some dates. So the next session is on the 20th of May. With Stuart Cunliffe, and the title is yet to be decided, but it will be a PowerVC and Ansible session. And then on the 10th of June, we've got Nigel Griffiths talking about what's new from Mr. Enmon, so new stuff in power systems and AIX and Linux. So it's a bunch of things that he will be talking about in terms of new news. So I hope you can join then. And then on the 15th of July, we have got Stuart Cunliffe again back to talk about OpenShift, Red Hat OpenShift 4.3 on power systems. And all of these speakers, as you'll probably know from the past, are very good at demoing what they are talking about, or giving you a great deal of detail and hints and tips. So I hope you can join us on those dates. Right, back to you, Gareth.
Okay, thanks, Jotty. Very useful information. I'm looking forward to some of those new sessions, particularly Nigel's talk, and also actually Stu Cunliffe. He's a very good guy. He sent me some good information that I was hoping to incorporate into this session, but unfortunately I'm just not going to have the time to talk about that stuff, but maybe ammunition for another session. So this particular slide here is talking about a little utility called EZH. That's the way that I pronounce it, EZH or EZH, short for Easy HMC Command Line Interface, written by this chap here, Brian Smith. Very clever guy. He's holding, I don't know, is that a Power 6 computer or Power 7 computer, I don't know. He wrote this quite a long time ago, 2012. It's got a load of LPAR related commands and dynamic LPAR. Very, very useful little utility. You can go off to http://easyh.sourceforge.net and you can download it. It's about 650 lines, I think, of code, and you can install it onto your HMC. Page down. No, okay. Let me. No, I'll come back and do a little bit of a demonstration. You can download it. There's also a link to a video that he's got. What you do is that you put it onto your HMC in your home directory, and then you source EZH. So you // EZH, and then you can either run EZH and it gives you a sort of a menu system, or you can run individual commands. So for example, you can type in LPAR, hit the tab key a couple of times, and it will expand out and show you all of the LPAR commands. As I say, I'll give you a bit of a demonstration later on. It's a bit difficult in WebEx to switch between a presentation and a demonstration and backwards and forwards, so I'll do it at the end. So I'm encouraging you to think outside the box, because apparently saying that there's more than one way to skin a cat is not politically correct these days. So there's more than one way to cook a potato. So just because you think you can't do something one way, there might be another way to do it. So for example, somebody on, I think it was on Twitter, came across this, that somebody was saying, oh, I can't run uptime on my HMC because the uptime commands are not there. Well, yeah, don't run uptime. Simple answer. So ways of finding out when you booted your system, well, you can look at the timestamp on the boot log. So here you can see that we booted, the boot log was touched at 9:03 on April 26th, or probably a better idea, you can run who-b, and it will tell you that your system was booted at 8:57. So yeah, it took a few minutes for it to come up. Okay. Another thing you can do is cat/proc/uptime, and it will tell you the number of seconds of uptime and also the number of idle seconds. But hang on a minute. So how come it's been idle for 6 million seconds and it's only been up for 140,000 seconds? Okay, well, if you, I thought I talked about that. Well, in fact, this HMC has got more than one processor, and so the amount of idle time is the amount of idle time across all of the processors, and the seconds of uptime is how many seconds it's actually been up. Now, moving across to the VIO server, we spent quite a bit of time on the HMC, and most of it actually applies to the VIO server as well. But a few things here to talk about. If I just move that out of the way, yes, in our home directory, we create a command called ioscli.log, and that contains quite a lot of the information about what we've actually been typing in at the system. If we run iOS level greater than iOS level.out, we can't do it because we are in a restricted shell. But this is interesting. You can redirect the output on a VIO server using the T command. I think that this is something that IBM forgot about somehow, but you can actually redirect in your restricted shell using the T command. So there you go. As you can see here, it created the iOS level.out and created it correctly. So what AIX command did a VIO command actually run? I got this from Alex Abrazak. I don't know how he found it out, but if you export CLI_debug equals 33, when you run a command on the VIO server, it gives you all of the AIX commands that it actually ran. Now, that may or may not be of use, but it certainly, I found it very interesting when I found out about it. It lets you understand what the VIO server is actually doing. On the VIO server, you can find your history using the FC shell built in, so fc-l. You can give it a number to give you the number of command histories it's going to actually show you. There's also the lsgcl command, and it just gives you slightly different information, so that's useful to find out. So sometimes you did something and then you're trying to remember what command syntax was so you can put it into a script. That's quite a good way to find out what you've been doing. And I got these two bits of information from a colleague in Australia, Chris Gibson, CGibbo, at CGibbo on Twitter. Very clever guy, very useful information. If you print CVAI, or you can echo it, this is on an AIX machine, piped into KDB, which is the kernel debugger, and then you grep vscsi, and you exclude any lines with the word read on it, you get vscsi, and you can see your vhosts on your VIO servers. So you can find out which vhost on which VIO servers actually provide you with the vscsi information. But do remember what Doug Gwynn said. You need to be careful. KDB, the kernel debugger, if you get things wrong, you can run KDB on the command line interactively. And as root, you can change memory in the kernel. So you can easily crash your system. So actually, this is a nice way of doing it, because it means you're not doing it interactively. You're far less likely to cause any problems. And this is a safe way of actually running things. But hey, you might be running NPIV, and this allows you to find out information for your VFC host, your virtual fiber channel hosts. So actually, that should say the NPIV there. Okay, now you might have heard of Nigel Griffiths. He's written some very useful things, including some great little scripts for the VIO servers. And if you go off to this particular website, you can see a nice little suite of tools here: ncluster, NLU, npool, nmap, and there's a thing called nslim, which you need to be very careful of. Nslim is not actually a script, but it's mentioned there. It's a way to take a thin logical unit and to copy a fat one and make it into a thin one. So you need to be careful with that. You can do some damage, but there are some useful scripts here. So very useful two-liner, ncluster. So this goes off to your shared storage pool, and it gets the status for your all the VIO servers in there. And rather than examining the text here, I'm just going to show you what happens on the output. Now, it does take generally between 5 seconds and a couple of minutes to run. That's not because the script is slow, it's because the cluster command is slow. It's got to do a lot of work going out to find the information on the VIO servers, and it comes back. And Nigel's script here shows you the state of the VIO server, the repository level, the pool level, and also the database node, the node which is actually running as a master for the SSP. Now you might think, Gareth, why are there so many VIO servers which aren't running? Well, as you know, we've got this virus going around. The machine room is they're taking the opportunity to do some work on the air conditioning machines, and so we've actually powered down a lot of our servers at the moment. So that's why many of our VIO servers are down. But nice command there, Nigel. Thanks a lot. That's very, very useful. There's also npool, which shows us storage pool usage. So you can see the name of the pool is globular, the pool is specific, and you got information about the utilization of the pool. Very, very useful. These, as I say, these scripts you can download, and you can see the way that they're coded. And we got NLU-HC. This is the new, or the Nigel's version, I should say, of the LU command. It gives you better layout and better ordering. You can choose which column you're going to actually sort them on. And so rather than just by name, you could sort them by the size of them in megabytes or the amount of megabytes which is used. So that's, again, a very useful command. Again, these are available for free download. And the nmap command allows you to see if a particular LU is mapped anywhere on the SSP. So you can see here, for example, I've said nmap SSP volume 2, and you can see here it's sitting here in red VIOS 1. Okay, so just a couple of pointers to some resources. There are lots of red books talking about the HMC and also the VIO server. There's lots of information in developer. Developer Works has kind of gone away, but we've now got developer out there, and there's also standard things in Knowledge Center. So let me come to here, stop sharing, and go and share a web browser. And then if I go to here, so here is the EZH website at SourceForge. And so you can see here there's a video, a link to a video on YouTube. And if I scroll down, you can see these are some of the commands that you can do for the DLPAR, and some of the ones that you can do system level or frames, dynamic DLPAR, and miscellaneous. So not bad for 600 odd lines of scripting. You can get an awful lot of stuff done. Now, if I now stop sharing that and I start to share, I need to start sharing content. I think it's that one. Yeah. Okay, so if I SSH to scripter at HMC 16, I haven't exchanged SSH keys for this particular one, so I need to enter a password. I think that's it. Yeah. If I do an ls in here, you can see that I've got my set variables. So if I say echo $red, it's not set. But if I dot space set variables and say echo $red, it's now set. And you can see I've also got the EZH file there. So if I run EZH, it won't work because it's not on my path. But I can run dot space EZH, and that's read the whole of the EZH command, file into my shell. And so now, if I run EZH, EZH runs because EZH is actually now a function within my born again shell, my bash, my restricted bash. So I can say, show me the DLPAR related commands, and you can see the sort of things that we've got. One of the nice ones actually is 16, which is going to show me the command that I'd need to run. Let's see here. Show me the command that I need to run to recreate or to duplicate the DLPAR. It gives me a list of the DLPARs. And for example, if I say, let's pick 35, which is my home DLPAR, that's the command that it would need to run. Now, that would be if you were, for example, cutting and pasting it straight into a shell on the HMC. If you were trying to run it remotely, you'd have to go through all of the quoting that I was talking about earlier. So that's showing me that. I press enter, brings me back to this screen. You can run other commands which are on here, or for example, you could say Q for quit, takes you back a level. I could look at 2 for DLPAR commands, and I can say DLPAR CPU, for example, which is number 1, it gives me a list of the LPARs to choose. 35, I'll pick which is my one again, enter a command, 1 to 35, so this is the number of CPUs. I'm going to say +1 to add 1 CPU. Oh, it won't let me do that because I'll exceed the maximum. Okay, so let's go 1 DLPAR CPU, 35, and we'll say -1. I'm just picking the wrong thing to do, but you get the idea. It's a very powerful little command here. So quit again, and so for example, miscellaneous commands. We can take, for example, 7, and we can see the events which have been happening on the HMC. So enter and then quit and then quit, and if I cat EZH, you can see, maybe what I should do is RNVI -F EZH. Here we go. You can see the coding which you've got in there. So the coding is very similar to what I've been talking about, but it covers a lot of different things. So very powerful little command or utility there, and it's freely available for download from the website. So let me stop sharing, and anything else that I can help with in the questions?
Most of the questions, Gareth, have been covered by Nigel.
Nigel.
Thank you. And or others in the group, and also there were some specific queries about the webinar and recordings and things like that, which Nigel and I have also answered. So I don't think there's any more questions that I can see at this moment. If you have any questions, please do pop them into the chat window. We can stay on for a couple more minutes.
Or indeed send email. I'll do my best to help. I'm not going to offer to write your scripts for you, but I'll certainly field questions.
Great. Thank you so much, Gareth. That was a fantastic hints and tips, I think, session. Best practices, scripting, CLI, lots and lots of commands covered there, and helpful little scripts. So thank you very much.
Own up to being old enough to remember punch cards?
Nobody that I can see in the chat anyway. Nobody who wants to make it public, even if they do. I do actually remember them.
I can put my hand up to that one. Yeah.
Yeah, me too.
They were all ripped out the summer I left university. I was just born too early.
Oh. Thanks to Nigel as well for fielding some of the questions. I just want to reiterate that the next session is going to be on the 20th of May with Stuart Cunliffe, and it will be related to PowerVC and Ansible. It will be at 2 p.m. UK time, so BST, British Summer Time, 2 p.m. and it's a 90-minute session. So I'm going to stop the recording there, and then we can stay on for a couple more minutes. Thank you all for joining.